So for our first one here, remember when we're dealing with right triangles trying to find missing sides, the first thing we have to do is identify which sides are the legs and which side is the hypotenuse. So on our first one here, what are the legs?
8 and 17.
8 and 17. So I'm going to call them A and B. And of course the hypotenuse would be X. So I'm going to call that C. And our formula is A squared plus B squared equals C squared. So I'm going to put in 8 for A, 17 for B, and then of course X goes in for C. Then what do we do? 8 squared is 64. 17 squared, 289. That still equals X squared. And then we got to add them together. 64 plus 289 is 353. And then square root. Square root of 353 is 18.789. And again, it would have to tell you how many decimal places it wants you to round it to. I didn't specify that here. Any questions on that one? So then for the second one, I guess I should put a variable here. I'm going to put this as y to find that missing side. What two sides are my legs? Y and 27. So I'm going to call those A and B. So then the hypotenuse, 45, would be C. So what's going to go in my equation here? Y squared plus 27 squared equals 45 squared. Okay, so y squared is just y squared. Plus 27 squared is 729. And 45 squared is 2025. Correct? What's next? Subtract 729. Which is going to give us, what, 1,296? Is that correct? So now we have to square root. The square root of 1,296 is 36. There's no squared there. So y equals 36. And of course, these are in feet, so the 36 is in feet. These are in inches, so the 18.789 is in inches. Any questions on either of those?
Can we do another one?
Sure.
I thought my calculator didn't factor out the 353.
When you oh, your calculator is on math type mode, so it's just going to give you the square root of 353.
You gotta click the button above enter. Above enter? The two arrows? Yeah.
That'll switch it into a decimal.
Oh, okay.
Yep.
Thank you.
You can change the mode on that calculator so it'll display it as a decimal rather than as the square root thing too.
Okay.
But every time you shut it off, you have to change the mode. So if you just remember to hit that button to change it, it'll do the same thing with fractions. They'll try to present them as improper fractions. You got to reduce them.
So I would hit that one instead of enter?
No, once you hit enter, then you hit that key.
Okay.
So let's do another example. So we're going to do 13 inches, 85 inches, and find x. I'll let you guys go ahead and try that in your notes. See if you can make that work. So let's see how you're doing here. What two sides are the legs? 13 and x. So we've got A and B. And then, of course, 85 is the hypotenuse. That'll be C. So A squared will be 13 squared plus B squared will be x squared equals C squared is 85 squared. Now, I could have switched the x and the 13. Either one could be A or B. Some of you may have liked having x squared first and then the 13 squared. That's fine. It works the same. So 13 squared is 169 plus x squared. 85 squared is 7225, correct? Now what? Subtract 169. So x squared equals 7,056. So the square root of x squared is just x. Square root of 7,056 is 84. And that is correct. That is 84, and the units here are inches and inches. That is also inches. Now, it doesn't have to be so nice and neat as that one. Some of you are thinking that was neat. We could have this one is 2 inches. This one is 4.8 inches. And find x. See how that one comes out. So once again, what's the 2 legs? 2 and 4.8. X is the hypotenuse. So that'll be C. So 2 squared plus 4.8 squared equals x squared. 2 squared is 4. 4.8 squared is 23.04, 23.04. So now we're going to go ahead and add 4 and 23.04 is 27.04 equals x squared. And then square root, which will give us what? 5.2 equals x. These are in inches, so this is in inches. How many of you had that one? Cool. Now, you want another one? Okay, we can do one more. We got 31 feet there. $481 feet here. Find x. Okay, so the legs are 31 and x. So we got A and B. And so the hypotenuse is the 481. That'll be side C. So x squared plus 31 squared equals 481 squared. X squared is just x squared. 31 squared is 961. 481 squared is, what's that? 231,361? Okay. There we go. Now what? Subtract 961. So x squared equals 230,400, sorry. And then we square root it, and the square root of 230,400 is 480. Feet, exactly. Good call. It depends on what it is. A lot of times in my math, I'll have the feet right after the box. So you don't have to put it in. On a test, I would maybe write in the feet if I was grading it, but I probably won't take off points for it. But now, if you are in one of the medical fields and you're taking the math for health professionals, in that class, you will lose points if you do not have units on it. Because, of course, 23 milligrams and 23 micrograms is the difference between a nice, happy evening and overdosing on morphine. So, yeah, there it will be. Of course, in the medical programs, also, if you do not put 0 in front of your decimal point, it's wrong. 0.6 would be marked wrong. It'd have to be 0.6. That's just to avoid mistakes is all. Okay, now, since we're on this topic of the Pythagorean theorem, or a squared plus b squared equals c squared, we had a question before you left last time. Where he went, how far south? 9 miles south. Then he turned and went, how far due west? 12 miles due west. Now, according to our calculations, he should have been 15 miles away, right? A squared plus b squared equals c squared. A right triangle, he should have been 15. But he wasn't 15. How far away was he? 9 miles away. How is that possible? How can he make a perfect right turn? And no, he did not turn a little bit too sharp and came back. Well, the Pythagorean theorem applies on a piece of paper, which is flat. His camp was not on a piece of paper, it was on the world, which is round. If his camp was at the North Pole, and he went 9 miles south, and then turned and went 12 miles due west, he is still 9 miles away from the North Pole. Therefore, the bear was white.
I told you.
You got it right? Cool.
I like my answer. Good one.
You must have started at the North Pole.
Yep. And a lot of people ask, well, couldn't it have been the South Pole? Well, how do you go due south from the South Pole? Jump? Flap your arms? I don't know. So there it is. How many of you had that? Cool. Good thinking. Yep, I'll remember.
All get extra credit?
Yeah, I'll get that point. Those points put in
No homework, right?
So that laugh may have been a little bit more cynical than I wanted it to be. Anyway.
Yeah, an A for the semester.
So our next step, now that we've established the color of our bear, we're going to keep going with our right triangles. I'm going to take a step back and we're going to look back at some of our geometry stuff again from a different angle. We said that all of our geometry came from that figure there, the point, or a location. And we created a segment by taking that point and dragging it in a single direction. Pretend that's straight. And we said the length of that segment is equal to the distance that we moved it. And then, of course, we went on to take that segment and drag it, or that point and drag it in a single direction forever to create a ray. What I want to do this time now is I want to take that length, take the whole length of that whole segment, and I'm going to drag it in a second direction. Now, we discussed right angles last class, and we discussed the term perpendicular. Perpendicular means right in every possible measurable way. So we're going to take this segment and we're going to drag it perpendicular to the original direction. So in this direction. Now if you think of that as being a stick being pulled across the sand, it traces out a rectangle. The size of that rectangle, the amount of land that rectangle covers, is defined to be an area. Area is the amount of surface that's covered. The size of that area, now of course this is perpendicular, so that's right angles there. Of course that means these are right angles. The size of that area is dependent on the length of the original segment and the length, or the distance that we pulled it here, this distance. That distance is often called a width. Sometimes called a height, all sorts of other names get thrown into it. So an area is equal to a length times a width. So if I have a rectangle, let's say the original length here was 18 inches. And I pulled it here in this direction for 7 inches. To find its area, it'll be 18 inches times 7 inches. Now when I multiply numbers, I multiply the counts. 18 times 7 is 126. But I also multiply the names. Inches times inches make inches squared. Very good. So the area of that rectangle is 126 inches squared, or 126 square inches, depending on how you want to pronounce it. Means the same thing. So here we have another rectangle. This is 12 feet and this is 9 feet. Its area is going to be, and I'm just going to start writing a capital A for area from now on. Its area is going to be what? 9 feet times 12 feet, or 12 feet times 9 feet. Doesn't matter which way we do it. Which will give us 108 feet squared, or square feet. In your notes, find the area of that. So we're going to take 37 centimeters times 11 centimeters, which will give us 407 centimeters squared. What do you think? Not so tough? Now here's the cool thing. The reason I define an area to be this way, rather than just being a length times a width, the reason I define it as being a length times a distance moved is because it doesn't have to be a width. If I take that segment, let's say that this is 12 inches. I can pull that segment, like we did before, perpendicular. Let's say I pull it for 5 inches. The area, of course, is 12 inches times 5 inches, or 60 square inches, 60 inches squared. But I don't have to pull it perpendicular. What I have to do is pull it so that the orientation always stays parallel to the original. Notice here, oops. Doesn't matter if I'm pulling it perpendicular, as long as it's staying parallel to its original orientation. I can pull it off at an angle like this. Now let's say that now I pulled it, and this distance is 7 inches. This is still 12 inches. Is my area 12 times 7? No. The area is not this distance. The area is the distance between where it started and where it ended. If that's 5 inches still, the area of this would be 12 inches times 5 inches, or still 60 inches squared. Now, I had to give you that 5 inches. If you're asking where did the 5 inches come from, I had to give it to you. In a little bit, we'll look at how we could find it. But for right now, I told you that that was 5 inches. But when we calculate area, we have to use two dimensions that are perpendicular. Here, the 12 and the 5 were perpendicular to each other. Here, the 12 and the 5 are perpendicular to each other. The 7's meaningless. It goes off at an angle. But if you think about this as like a stack of papers or a stack of really thin pancakes or whatever, the area they cover, it doesn't matter if I slide them off to the side like this. It's still 5 inches high, and it's going to be the same number of them that it takes to stack up. So the area of the ends will be the same. I've just slid them off to the side a little bit. In fact, one of the cool things is I don't even have to slide it straight. Let's say I'm at 12 inches. let's say I want to do something funky like this. Oops, get back here. So now let's say that it moved something like that. I'm going to cheat because I suck at drawing. There. As long as this distance from where it started to where it ended is 5 inches, the area is 12 inches times 5 inches, or 60 inches squared, square inches. Because again, you think of those stacked up pancakes or whatever you're looking at there. It's going to take the same number of them to stack up 5 inches thick, no matter how they're sitting on each other. Now, we're not going to do anything like this, but we will do things like this. So find the area of, let's say this is 15 feet. And of course, we need this dimension. Let's say that is 18 feet. Find its area quick. So of course that'll be 15 feet times 18 feet, which is 270 square feet. Seeming pretty easy? No. I was waiting for that. No, it's horrible. Don't do any more. Okay, so let's say that this is 24 inches. And let's say that we are told that this piece over here is 20 inches. And this piece here is 12 inches. Can I find the area of this? Okay, do it. Where do we start?
X squared plus 12 squared.
Okay, make this x for our height. And that's exactly right. That's sides A and B. The legs are the 12 and the x. I'm going to do this. I'm going to make that A and B like that so it matches what you said. So it's x squared plus 12 squared equals 20 squared. And at this point, I'm going to trust that you guys can do that part of the equation. What's it come out to be? X equals 15, right? 16? Okay. 16 inches. Now what? Now we can do the area. The area is the 24 inches times the 16 inches, or 16 times 24 works the same, which is going to give us 384 inches squared. How many of you had that? No? Do you want to try another one?
Yes.
Bless you. Bless you again. Find the area of that triangle. Okay, first of all, what's our height? 40 centimeters. Everybody, who got 40 centimeters? Okay, so we're on the right track there. So then the area is 30 centimeters times 40 centimeters, otherwise known as 1,200 centimeters squared. Perfect. Who got that one? Okay. You feeling better about them? Good deal. This is what we call a trapezoid. Very good. Why? I have no idea why they call it a trapezoid. But what makes it a trapezoid is we have one pair of opposite sides, or two opposite sides that are parallel to each other. Those are called the bases. Normally what I do is I make the longer one base with a capital B and the smaller one base with a little b. So I can distinguish between them as little b and big B. Okay? Let's say that this trapezoid here is 12 inches on top. Let's say it's 15 inches here. 15 inches between the bases. And let's say the bottom here is 30 inches. We know how to find the area of a rectangle. And we know how to find the area of a parallelogram now. But mainly the parallelogram, one of the reasons this parallelogram works is because I can take this triangle right here, I can cut it off, and I can move it over here. Now what do I have? I have a rectangle in there, right? So basically the only thing I know how to find the area of is a rectangle. So this trapezoid somehow has to be turned into a rectangle. Now it's not as easy as it was with the parallelogram. I can't just chop the triangle off of one side and move it to the other. But here's what I can do. I can go halfway down this side, right there. And I can chop this off square. So that's a right angle. If I flip this little piece up here, what happens? It should fit exactly in there. And fill that in. I squared off one end. I can do the same thing to the other side. Go halfway down, chop this off square, and flip that piece up. There it is. I now have a rectangle. What's the height of this rectangle? Still 15, right? That hasn't changed. The distance between the bases is still 15. What has changed is this length. It's now longer than 12, but shorter than 30. In fact, it is exactly between them. How do I find a number that's exactly between two numbers? I average them. I add them together, and I divide by 2. So 12 plus 30 is 42. Divided by 2 is 21. So this is really a triangle that is 21 inches by 15 inches. Warning here before we move on. When you put this in your calculator, 12 plus 30 divided by 2, do 12 plus 30, then hit equals before you divide by 2. Otherwise, what your calculator will do is it'll divide the 30 by 2 and get 15 and add it to the 12 and give you 27. Not the right answer. So be careful with that. So the formula, the area of this here is just going to be the 21 inches times 15 inches, otherwise known as 315 inches squared. So the formula for the area of a trapezoid is to average the bases and then multiply by the height. Does that make sense? No? Let's do a few examples, see if that helps. So leave that formula up there. So let's make this 13 centimeters. Make this here 10 centimeters. And let's make the bottom down here 27 centimeters. So to find the area, I average the bases. What are my two bases? 13 and 27. So 13 plus 27 and then divided by 2. Now I'm going to that gives me what would be the length of this related rectangle. And I'm going to multiply that by the height of 10. So 13 plus 27 divided by 2 is, better be 20. Times 10 is 200 centimeters squared. Okay, So when you punch in your calculator, 13 plus 27, hit equals. Now divide by 2. Gives you 20, right?
Yeah.
Now that times 10 gives you the 200 centimeters squared. So on this one, find my area. What are my two bases? 35 and 9. So it's 35 plus 9 divided by 2. And that's going to be multiplied by the height of 20. So let's do 35 plus 9 divided by 2, which gives us 22. Times 20 is 440, and that is inches squared. Where'd the inches come from? Everything is in inches. What's that? Does that answer your question? Okay, sorry. Surprising timing on that one, by the way. What's wrong here?
Your words aren't matching.
My units don't match. All of the units have to be the same. Now it's easier to go to the smaller unit so I don't end up with fractions or decimals. So this is 8 inches. I can convert 1 foot into how many inches? 12 inches. 2 feet? 24. Now I'm not saying the homework will necessarily give you problems with different units, but before you start cranking out an area, you do have to make sure everything is in the same units. I think in the homework, the only thing it mixes, it might mix millimeters and centimeters together or something like that. It doesn't do feet and inches. So anyway, now that I have that, how do I find the area of this? Not 8 plus 2, but 8 plus 24. Divided by 2, and then times 12. So 8 plus 4 is 32, divided by 2 is 16, times 12 is 192 inches squared. How we doing? Having fun yet? You need a drink? Pretend the
Getting bigger and
Yeah.
fine. Happy now?
I can't see it. It's like you're married.
Now I need a drink.
Glass full of lemon and then
Okay, so in your notes, find the area of that. It is all in inches, so you don't have anything to convert. Okay, so what goes in here? 5 plus 13 over 2 times 4. Okay, so 5 plus 13 divided by 2 is 9 times 4 equals 36 inches squared. Sometimes we run into something like this. Even though that doesn't go between, the bases don't even line up on each other. Now this is side to side. The height of this is still this brown line here. The bases don't have to be top and bottom. They just have to be the two sides that are parallel. And the 4 and the 16 inches are parallel. So let's make this 13 inches. To find this area, we would what? 16 plus 4 divided by 2 times 13. Which, if you do that out, confirm 130 inches squared. So you do need to get used to other orientations. That is still a trapezoid. A very ugly one. I may be terrible at drawing. There are certain things I can draw well. A straight line is not one of them. Unfortunately. I do fairly good stick figures. So how do I find the area of this? 21 plus 5 divided by 2 times 30, which gives us 390 square feet. Feet squared. Perfect. I'll give you some time with that one. You don't like those? I got a good one for you.
Of course you do.
Actually, that's wrong. That's going to be 13 feet there. Sorry. Find the area of that trapezoid. It is break time, by the way, so we're going to go ahead and take our break right now. We're going to come back in 10 minutes. It's 4:21. We'll come back at 4:31. And when we come back, we'll spend some time finding the area of that trapezoid.